Alrighty, so today we're going to start talking about evaluating our linear equations using function notation. Basically, function notation is f of x. It is a replacement for y, so it's something that we can replace with y, with f of x. So written as an equation, we could have y equals 5x. In function notation, we take out this y and we replace it with f of x. If y equals x plus 7, then g of x equals x plus 7. So you just want to replace it with this function notation. This piece here is kind of important. F of x does not mean f times x. F is the actual name of the function, and x represents the input that goes in. So again, f is the name, x is the input, x plus 2 is the rule that you follow to get the output. So it's a rule that you follow. So again, function name, input, output. You can use any letter, but the most common letter is F for function. But a lot of other common ones is G of X and H of X. So when we want to evaluate a function, we just want to replace, substitute its variable with the given number. So we're going to do the same thing. I'm going to show it's exactly the same as using y as if we use function notation. So if we did it with y, we would say y is equal to minus 4 times 2 plus 7. We get minus 8 plus 7. Then you would tell me y is equal to negative 1. Using function notation, we're going to say, all right, I'm going to evaluate function f when x is equal to 2. And then anywhere you see an x, you're going to replace it with 2. So minus 4 times 2 plus 7. That's minus 8 plus 7. And then we say the function when x is 2 is equal to negative 1. Let's just try it with a different number. We've got negative 2 here. So if we're just using y, we would replace x with negative 2. That's going to give us 8 plus 7. So y is equal to 15. Using our function notation over here, f of negative 2. So function f I'm evaluating when x is equal to negative 2. So anywhere we see an x, we replace it with negative 2, following the rule that's given. So we find f of negative 2 to be 8 plus 7. So f of negative 2 is equal to 15. So it's exactly the same thing. It's just a different notation. Most higher math is done in function notation, so it's definitely something we want to get used to. I'm going to show you a few more examples here, and then I'm going to let you try some on your own. I'm going to evaluate function f, which is equal to 8 minus x when x is equal to 3. So the function at 3, function f at 3, I'm going to replace x with a 3 and evaluate. F of 3 is equal to 5. I'm going to do the same function, but now I'm going to evaluate function f when x is equal to negative 4. 8 minus negative 4, these two negatives will become a plus. So we find f of negative 4 to be 12. And the last one we're going to evaluate is f at 0. So what's function f when x is equal to 0? We put 0 inside there, and we find f of 0 to be 8. All right, guys, so I'm going to let you try a couple on your own here. So try that one on your own. And I think we're missing one. All right, so I'm going to let you try those on your own. I'm going to go ahead and just show you how to solve these problems here, and then we can try. I'm going to let you guys try it. So I've got 3 functions here, all with different names. One is function f, function g, and function h. If I want to know what is g of negative 3, make sure you go to the g function. And anywhere you see an x, you're going to put in a negative 3 and solve. It's going to get you 3 plus 2. I'm putting the answer down. So g of negative 3 is equal to 5. If I want to solve for h of 6, I need to make sure I go to function h, which is this guy over here. We substitute in 6 anywhere we see an x. That's going to get you minus 24 minus 5. So h of 6 is equal to minus 29. And the last one I want to do is I want to find out what's f of negative 4. So make sure you go to function f and use its rule. So f of negative 4 is not enough space over there. I'm going to rewrite this. It's going to be 2 times minus 4 minus 6. So minus 8 minus 6. So f of negative 4 is equal to negative 14. And that is how we evaluate our linear functions using function notation.